Hello, friends. Have you ever wondered how a tiny lizard, could hold the key to the future of space exploration? So, stick around, friends, as in this video, we will dive into the incredible science behind the gecko feet and how their unique adhesive power could revolutionize space travel. Discover how engineers are using this natural phenomena to develop new grippers, tethers, and climbing robots for use in zero gravity. So, friends, hello and welcome. So, when we think of the danger of space, we often imagine the meteoroids, solar radiation, and other things like cosmic rays. But one of the most persistent and the surprising and common problem for astronaut is something much simpler, which is losing the grip. Imagine you're an astronaut and floating in the vacuum of the space, performing a spacewalk or an EVA and extravehicular activities. Your life depends on being tethered to the spacecraft. A single tool, a wrench, or a screwdriver, if it slips from your fingers, it's gone forever. A tiny, insignificant object drifting away into the cosmic void, and if you lose your grip on the situation itself, that is the ultimate life threatening disaster. So for decades we have rallied on clunky mechanical clamps, tethered, and simple but limited solutions for things like velcro, etc. But what if there are better ways, a way to give astronauts the ultimate superpower, the ability to stick to any surface at will and then go without a trace? The answer it turns out, is hidden in the plain sight on the feet of a tiny house dwelling lizard. Today, we are going to explore how a gecko's toe could save the astronauts and revolutionize the space travel. To understand how gecko could help us in space, we have to understand the magic of its feet. This isn't a matter of simple suction or sticky goo. A gecko's incredible climbing ability is based on the fundamental force of physics. If you like, if you like this subject, stick around, because till the end we will learn so much stuff about what is going to happen in future. Now, look at the gecko's foot, and you need to microscope to really see what is going on here. You notice that it's not too smooth. The toes are covered in very tiny layered ridges called lamellae. Each lamellae is covered in millions of microscopic hair called setae, and at the end of each seta there are even smaller flattened pads called the spatulae. These spatulas are often the real action. This is where the real action kings. They are so small that they can get incredibly close to the molecules of any surface. And when two molecules get close enough, they feel a slight temporary attraction. This is scientific principle known as the van der Waals force. Think of it like a molecule handshake, a slight universal force that exists between all atoms and the molecules. It's incredibly weak on its own, but when we have millions of these tiny molecules handshaking happening at once, the force adds up to something truly powerful. A single gecko weigh just a few ounces can support its entire body weight with a single toe. If a human had the same level of adhesive power, we could climb a vertical wall with one hand. And here is the most important part of the space travel. Van der Waals force didn't require air or vacuum. They work perfectly in vacuum of space, and when gecko lifts its foot, the force breaks leaving no residual behind. It is the ultimate reversible adhesive. Now that we understand the gecko's secret, let's revisit the challenges of working in space during a spacewalk. Astronauts are constantly at risk. The environment is harsh with extreme temperature swings and dangerous radiation. But one of the most pressing concerns is the simple physics of zero gravity. Every tool has to be meticulously secured. Astronauts use complicated tethers, bulky gloves, and mechanical fasteners. They have to constantly clip and unclip themselves from the spacecraft's handhold, and it's a slow, cumbersome, and physically exhausting process. Current solutions have serious limitations. Velcro is a decent option, but it degrades over time and gets clogged with debris. Magnets are great, but they only work on a limited range of metal surface and can interfere with sensitive electronics. And traditional clamps or grippers are heavy and add unnecessary weight to a mission. What astronauts really need is a simple, lightweight, versatile solution. A way to move with ease of gecko on a glass, and a technology that can grip any surface, metal, glass, solar cells, anything, and then releases that instantly with a flick of a wrist. This is a problem that has puzzled engineers for decades, but the solution was right here on Earth all along. This is where the real innovation begins. Researchers and institutions like NASA's Jet Propulsion Laboratory and various universities took the gecko's natural design and began to replicate it. But how do you recreate millions of microscopic hairs in a lab? The answer comes from the world of nanotechnology. Scientists began creating tiny carbon nanotubes, which are also known as hairs, that mimic the spatulae on a gecko's foot. These artificial hairs were, when they are bonded to a flexible polymer backing, creating what we call a dry adhesive. The first prototype were small patches that could be used to pick up a tiny object, but the technology quickly scaled up. The scientists developed handheld gecko grippers tool that could pick up delicate circuit boards or hold a bulky camera without a single clap. Perhaps the most exciting application is the robotics. Imagine a robot that can climb the outside of the International Space Station to perform the inspection and repairs. The robot doesn't need to be tethered or use any fuel. We've already seen prototype of such robots, sometimes called the gecko climbers, that can scale smooth vertical surface with ease. And for the astronauts themselves, the ultimate goal is to integrate these technologies directly into their equipment. Imagine gloves with gecko-like pads on the fingertips, allowing them to firmly grip a tool or a part of spacecraft without any fumbling, or boots with sticky holes, letting them walk along the exterior of the shuttle as if they were walking on a solid ground. This technology is no longer a science fiction. It has been tested in vacuum chambers and it is on the verge of being deployed. The simple idea, inspired by a lizard, has a potential to fundamentally change how we operate in space. With gecko-inspired technology, spacewalks become safer, more efficient, and less physically demanding. Astronauts can spend less time struggling with equipment and more time focused on their mission. But the application don't stop at the International Space Station. Imagine future lunar missions where astronauts can use gecko adhesive to navigate rocky terrain or stick on the side of a habitat and perform their missions or repairs, etc. Picture rovers on Mars that can climb sheer cliffs to access new geological data. Think of the missions to asteroid where robots can anchor themselves to the surface without a tether or a harpoon, because on asteroid the gravity is very low, so they need to they need to be fastened to the asteroid. Now moving on, this is a perfect example of the biomimicry and practice of taking inspirations from the nature to solve human problems. If it reminds us that some of the most elegant and effective solutions aren't found in a textbook or a computer model, but in the millions of years of evolution that have perfected life on our planet. From the streamlined body of the shark that reduces drag to the intricate design of the bird's wing that allows flight, nature has already solved many of the engineering problems that we have faced. So, next time when we see a gecko effortlessly climbing a wall, remember that it's not just a tiny lizard, it's a living blueprint for a new era of space exploration. It is a reminder that no matter how far we travel or how advanced our technology becomes, the most brilliant innovation often comes from the simplest and most elegant design found here on the surface of the earth. So, from a microscopic force to a grand mission, the humble gecko is helping us take our next great leap into cosmos. Friends, thanks for joining in today live and thanks for watching. If you have any comments, please leave them in the comment section below and I will catch you in the next one.